In this first part of the session dedicated to material creation, we will begin to explore the fundamental techniques that will allow us to develop realistic and relatively complex materials. We will also delve into the reasons behind some fundamental choices, providing a more detailed understanding of the creative process. Looking at the reference image, we can see that the sideboard is made up of three types of materials. A wood material for the central drawers, the top and bottom panels, the left and right side panels, and the back panel. A fairly dark gray laminate material for the two doors on the sides, and a dark metallic material for the supporting structure. To create a realistic material, it is essential to use three main types of textures, each with a specific function. Color or albedo texture. This texture determines the main color of the material. It is not affected by lighting or shadow. It only reflects the pure color as perceived under neutral light. Glossiness or roughness texture. These textures control the appearance of reflections on the surface of the material. The glossiness texture indicates how smooth and reflective a surface is, which corresponds to higher values. On the other hand, the roughness texture determines how matte the surface is and how it scatters light, with higher values indicating greater roughness. Normal or bump texture. Both enhance the surface detail of the material by simulating bumps and irregularities. While the normal texture uses an RGB image to directly modify the direction of surface normals and thus create the illusion of depth, the bump texture uses a black and white image to simulate bumps and depressions by altering the way light interacts with the material surface. Using these textures in combination allows you to achieve visually rich and detailed results, which are essential for realism in any 3D rendering project. We will also use the Anodi system to create the materials. This is a much more intuitive and clear approach when it comes to building materials. This method allows you to combine and modify textures visually, making it easier to understand and implement the physical properties of materials. Let's set up a new workspace to optimize the material creation process. We'll start again from the file from the previous lesson where we set up the lighting. And we'll split the viewport like this. We'll divide the workspace on the left into two parts. Set the top window to UV Editor. Click on Browse Image to be linked, and from the drop-down menu that appears, select the reference image. This way, we can always check the original materials. Leave the bottom window set to the camera view. Also divide the workspace on the right into two parts. Set the top window again to UV Editor and the bottom one to Shader Editor. In the outliner, turn off all collections except for the one containing the sideboard. Move to the bottom left window, the one showing the camera view, press the Z key and select Material Preview. We're ready to create the wood material. Select one of the sideboard's drawers. In the Properties window, open the Material tab and click on New. Rename the material to Wood. In the Shader Editor window, the two main nodes of the material, Principled BSDF and Material Output, are immediately added. What we need to do is connect the three textures, Color, Glossiness, and Normal, that define the wood material to the Principled node. Open Blender's Preferences window using the shortcut Ctrl, or by selecting the corresponding option from the Edit Preferences menu, and make sure the Node Wrangler add-on is installed. Click on the Add-ons tab and type Node in the search field. Check that the box for the add-on is enabled. Select the Principled node and press Ctrl+T. Blender will automatically add the necessary nodes for inserting textures. Delete the Image Texture node. From the File Explorer window, locate the textures you want to add. Select them and simply drag and drop them into the Shader Editor window between the Mapping node and the Principled node. Connect the vector output channel from the Mapping node to the respective vector input channels of each of the three textures. The connection we just made allows you to control how the textures are applied to the model. This step ensures that changes such as position, rotation, and scale affect all the textures in a coordinated and consistent way, making sure they fit correctly on the object's surface. Now we need to connect the color output channels from each texture to the corresponding channel on the Principled node. So, connect the color output channel from the color texture to the base color input channel of the Principled node. Connect the color output channel from the glossiness texture to the roughness input channel of the Principled node. Connect the color output channel from the normal texture to the normal input channel of the Principled node. The drawer of the sideboard is now shown with the wood texture applied. However, there are still a few operations left to complete. Let's see what they are. Let's focus on the shader editor, paying particular attention to the glossiness and normal textures for a detailed analysis. These two textures do not contain color information capable of representing visible tones. Instead, they are maps that influence the physical properties of the surface, such as reflectivity and the perception of depth. As we can see, the color space parameter for both is set to sRGB by default, which tells Blender to interpret the textures with gamma correction, intended for color images that simulate how the human eye perceives light and color. This can distort the data in textures like glossiness and normal, which provide purely technical data not meant for visual color perception. By setting these textures to non-color, you ensure that the values are interpreted literally as data without any gamma transformation, preserving the integrity of the original data for more accurate use in reflection, shading, and texture calculations. This is essential for achieving realistic and technically correct results in 3D rendering. That said, let's set the two parameters of the glossiness and normal textures to non-color. Examining the connections, we notice that the color of the link between the normal node and the corresponding channel of the Principled node fades from yellow to purple, indicating that the connection is incorrect. To have the Principled node correctly read the normal node, we need to insert the normal map node. Once again, I think it's important to delve into the reason for this operation. The colors of the connections between nodes indicate the type of data being passed. The color change from yellow to purple suggests that you're trying to directly connect a normal texture, which has a yellow output, to an input that requires a normal vector, which is purple, in the Principled BSDF node. This direct connection is not correct because the data are not compatible. The normal map node is necessary because it converts the normal texture data, which is an encoded representation of how light should be reflected from the surface, into a modified normal vector that the Principled BSDF node can use to correctly influence the appearance of the surface. Without the normal map node, the information from the normal texture would not be interpreted correctly, leading to unrealistic or otherwise incorrect visual results. The normal map node ensures that the texture correctly contributes to the surface detail effect and the visual depth of the material. Therefore, let's press Shift-A, type normal in the search field and click on Normal Map. With the node attached to the mouse cursor, we position it on the connection between the normal node and the corresponding channel of the Principled node. Now the colors match and the connection is correct. In this first introduction to creating materials, we have explored various fundamental aspects. In the second part, we will continue to delve into the wood material and explore how to further improve its quality and realism. For now, let's make sure to save all the work we've done progressively so we don't lose any changes we've made.